Great, thank you very much. Well, welcome everybody. This is Trish said. This is another one of our series of SBCA technical webinars. Today we're going to be discussing gypsum joint ridging and cracking, along with other issues involving gypsum board. Typically, then how they relate to the trusses or wall panels. And as Trish said, if you've got any questions, please feel free to type them into the chat area, and we'll try to address them in real time. Okay, here, let me get this. There we go. Drywall cracking and ridging are typically problems seen in ceilings and walls of homes. And we'll get into a little bit more detail, obviously, regarding these. They can be caused by many different, there can be many different reasons for the gypsum cracking. Some can be structural deficiencies. We're not really going to be talking about those today. These are primarily cracks that occur due to, say, differential shrinkage or movement of some of the different materials, construction materials that are used in finishing materials. The problem has become more widespread as homeowners insist on larger rooms and open floor plans. And they can also be directly related as construction times shorten and materials perhaps are not given as much time to condition before they move on to the next stage of construction. And also to some extent due to a decline perhaps in some of the quality of the materials that are used. In wood, if you know, as more plantation grown wood is being used, the effects that moisture have on that and its dimensional stability are significantly greater than if it was old growth. And also with, again, to some extent, the quality of construction, whether it's due to ignorance or whatever. So many different factors come into play. The cracking and ridging are common problems that typically occur along large open spans, and both can occur at the same location, and due to alternating periods of primarily high humidity, but also to some extent large shifts in temperature. Now, again, we're not going to be discussing problems with gypsum cracking, typically due to structural deficiencies. The photo on the left, typically what you're going to see if you go out on a job site or to investigate and you see more of a diagonal crack that's moving at a 45-degree angle off the corner of a door, let's say, that's probably a good indication there's some type of a deficiency in the structure, whether it's a significant deflection or differential deflection that's causing that crack at a 45-degree angle. The photo at the right obviously is a bearing issue where don't believe a column was installed in the wall where it should have been. And again, structural deficiencies, that's really not what we're going to be focusing on today. Cracks often develop in the center of tape joints running parallel to tapered edges or factory seams. This cracking may tear the drywall tape and grow over time, and it may vary in width cyclically as the seasons change. Ridges, on the other hand, are typically small humps in the surface of the gypsum, usually 1/4 inch to 3/8 inches wide, typically occurring along the tape joints, and are caused by compression of the panel ends or edges. Now, both cracking and ridging can occur cyclically in the same location. Cracks typically tend to show up during wetter periods of time, and ridging typically during the drier months. And again, as we stated earlier, with the trend towards larger rooms and open floor plans in recent years, this problem has tended to increase. Now, there have been several studies that have looked into this as to what the cause of gypsum ridging and cracking, what the causes are. The first group was sponsored by the Drywall Finishing Council, and they collected data using electronic monitoring system in 2 Las Vegas homes. The second group was a joint effort between the Drywall Association of Nevada and Monash University in Melbourne, Australia, where they actually constructed a framed wall test module, including ceiling and roof structure within a climate-controlled test chamber, and then varied the temperature and relative humidity over extreme conditions to try to see the effects that had. The vast majority, you'll notice that both of these studies were primarily focused on rather arid parts of the United States, and Australia obviously having a large area that is considered rather arid. The vast majority of the reported cases of GRC typically seem to occur in more arid areas of a country where humidity changes are the most drastic from season to season. The studies basically concluded that there's significant relative humidity changes, and I again stress the word significant, are likely the most significant cause, I guess I like the word significant, of gypsum ridging and cracking, primarily due to differences in behavior of the various construction materials when subjected to cyclical changes in moisture content. Now, other causes can also include poor framing practices and improper gypsum installation techniques. In terms of climate, when a residence or a building is constructed in the summer, typically, and it's subjected to increased humidity, and again, we're talking about more arid locations, where typically the higher humidity is going to occur in the wintertime, and the lower humidity occurs in the summertime. So when the residence or the building is constructed in the summer, and then at a relatively low relative humidity, and then subjected to an increase in humidity in the wintertime, most construction materials are going to be taking on moisture as the humidity increases, and they will tend to expand. I know wood is exactly that way. The framing lumber increases in length, and we'll talk about that here shortly, to a greater extent than the drywall will. And the differences in increased length causes tension in the drywall and can result in pulling the tape joints apart and cracking occurring. The opposite is true then when the same assembly, if it was constructed in the wintertime, when the humidity is higher, and then subjected to a lower humidity in the summertime and it starts to shrink, again, the lumber shrinks at a greater degree than the drywall. That will force the drywall gaps together and then causing the ridging. Let's talk a little bit about some wood technology as to why the moisture effects will change the wood. If we think of wood basically as a series of like soda straws, okay, the wood cells, and wood is obviously a lot stronger parallel to grain than it is perpendicular to grain. The chart at the right here basically shows that, okay, if these are my soda straws, my wood cells, at moisture contents typically about 30% or greater, so like in a living tree, there you have, not only are the cell walls saturated with moisture, but you also have free water typically within the cells. Now, and moisture contents can actually exceed 100% in terms of how they're measured. But in a living tree Anything, okay, moisture content greater than 30%, which is also typically known as the fiber saturation point, you're going to have free water, and the cell walls of the wood cells are also saturated with water. And anything above fiber saturation, you can vary the moisture content all you want, and it's not going to have any effect on the dimensional stability of the wood, or the strength for that matter. Once you drop below fiber saturation point, down towards, say, oven dry, 0%, what's happening now is you no longer have free water, and as you get drier and drier, what you're doing is you are removing water from the cell wall. And in doing so, you're breaking the chemical bonds between the water and the cell material. And so what's happening then is it's causing not only changes in the strength properties of the wood, because as you remove the water, the cell material now is able to form chemical bonds with its own material, and which typically is a stronger bond and makes the wood stronger. But what's also happening is as I'm removing the water from the cell is shrinking, and that's causing the dimensional change in the wood. Now, the amount the wood shrinks depends on the species that's being used and also the orientation relative to the grain of the wood. Shrinkage typically is greatest in the radial and tangential directions, or perpendicular to the grain, and is least in the longitudinal direction or parallel to the grain. Most of you have probably seen this. This basically shows for a given cross section of a log, depending upon where the material is cut from the log will kind of determine the if it dries and what type of warping and twisting could potentially take place. Now, I mentioned a couple of different angles or directions. The radial direction is basically if you start at the pith, which is the center of the tree, and work your way out in the radial direction. So I'm going perpendicular to the growth rings. The tangential direction is basically parallel to the growth rings. Now, typically, and again, it varies by species, but wood will tend to shrink. Its greatest shrinkage occurs in the tangential direction. And that can be anywhere from 5 to 8 or 9% in drying from fiber saturation point down to oven dry or 0. In the radial direction, it will also shrink, and the average, say, of about 3 to 4 to 5% going from fiber saturation point, or 30%, roughly 30% down to oven dry. And then in the longitudinal direction, which would be in and out of the screen, parallel to the strength, or excuse me, to the wood fiber orientation, that's where wood shrinks the least. And that is typically only about maybe a 1/10 of a percent or a 20th of a percent. So wood is much more stable in lengthwise, parallel to the wood fibers than it is either radial or tangentially. Okay, well, when you're manufacturing a truss or you're buying lumber, you really have no control over how that material is going to get cut out of the log. So you don't know if you've got a radial or tangential or how much you're going to have in that piece. And basically, and we'll see this chart again, this is a table that comes out of the U.S. Department of Agriculture's Wood Handbook, and it shows the relationship between moisture content in wood and temperature and relative humidity. We've got temperature on the y-axis and relative humidity in percentage along the horizontal. And what you see is for a given relative humidity with a temperature change going all the way from 30 degrees up to 270, For instance, if I have a 20% relative humidity, my moisture content is only changing from about 4.6% at 30 degrees and 20% down to only 0.3% moisture content at 270 degrees. So within keeping the relative humidity constant, but varying temperature, you don't get that much of a change in moisture content. On the other side, however, if I maintain a constant temperature, but I vary the relative humidity, now you can see, for instance, at 70 degrees Fahrenheit, going from 5% relative humidity, I start with a moisture content of about 13%, excuse me, 1.3%. And then at 95% relative humidity, my moisture content would be 23.9. Now, obviously, it takes wood a while to, you can't change the temperature and relative humidity and then 5 minutes later expect these types of moisture content changes. And in most applications, even if it's in a conditioned space, the temperature and relative humidity are fluctuating constantly. And so the moisture content of the wood is also fluctuating, but it's fluctuating at a slower rate. So typically you'll hear people reference it as equilibrium moisture content, which is, for the given ranges of temperature and relative humidity, what the average moisture content of that piece is going to be, over time. Now, as an example of shrinkage, let's use an example that from the Western Wood Products Association, where they basically say that for shrinkage of most Western species, and what I'm referring to there is typically Douglas fir larch, which would be a species group, or hem fir, which is also a species group, is approximately 6% perpendicular to the grain. Okay, so in other words, what they've done is they've taken an average of the tangential and radial and averaging over the typical Western species. You can expect a 6% change in dimension, or in perpendicular to the grain, or shrinkage, as wood dries from 30% moisture content to 0% moisture content. And then parallel to grain, you're talking about a 0.15% shrinkage as you dry from 30% to 0%. So perpendicular to grain, if it's a 6%, divide that by 30, because that's what I'm changing my moisture content as I go from fiber saturation to 0. So that's roughly a 0.2% shrinkage for every 1% change in moisture content. Conversely, in longitudinal direction, 0.15 divided by 30 is a 0.005% shrinkage for every 1% change in moisture content. So, for instance, if I have a 2x10 and it was installed at 18% moisture content and dries to 9% moisture content, because I'm drying it, I would expect it to shrink. And what this allows us to do then is kind of get an idea to calculate how much shrinkage we think we may see. So if the 2x10 is 9.25 inches times 0.002, which is 0.2% obviously as a decimal, times 9, which is my change in moisture content, I can expect about 3/16 of an inch. So this thing is going to go from a 9.25 to 9.25 minus 0.17, give or take. Which, okay, most residences, if you're using dimension lumber, big deal. But now if you're building something that's going to be a 3 or 4 or 5 story building, this starts adding up. And that's why shrinkage can become pretty critical, especially perpendicular to grain. Conversely, shrinkage, say in a 10-foot tall 2x4 stud, drying also from 18 to 9%, I have 120 inches times 0.005% divided by 100 is 0.0005 times 9, or that's only going to change over a 10-foot length about 1/16 of an inch. So again, wood is pretty stable in its dimension parallel to grain. As I said earlier, the studies basically showed that humidity levels haven't probably the most significant effect on when gypsum ridging and cracking can occur. However, typically the humidity levels must change by at least 50% and be maintained for 18 to 30 days for gypsum ridging and cracking issues to occur. And again, what you're seeing here is they change 50% and then are maintained for an 18 to 30 day period so that the relative humidity is changing, and as a result, the moisture content and the equilibrium moisture content of the wood, it's taking time to basically be either expelling moisture or taking it on, depending upon if the relative humidity is going down or going up, the 50%. It just takes time for things to start to move and change. So again, relative humidity change of about 50% or greater, and then maintained over 18 to a 30-day period. Temperature shifts do not have a significant effect on GRC, but they certainly can, and the effects are typically immediate within a 24 to 36 hours and are typically relatively small. And again, looking at this chart, we can kind of see where if I have a significant change in temperature, but I maintain a constant relative humidity, I don't care what your relative humidity is, you're not having much of a significant change in moisture content. However, if I go from relative humidity, let's say of 20, and I have a 50% change, and I go up to 70, and then I maintain that over a long period of time, and let's say my temperature is basically 70 degrees, I'm going from 4.5% up to 13.1, so a more significant change with changes in relative humidity. Other factors that can affect causing gypsum cracking. In certain parts of the country, as I'm sure some of you are aware, it's not uncommon to use unseasoned or wet lumber. Reason being that because it's more of an arid condition, the thought process is by the time the lumber gets installed and by the time the building is finished off, it's that moisture content of that wood is probably going to be down well below the 19% moisture content. But again, as we have seen, as that wood shrinks, that's when you get as it dries, that's when you get the more significant dimensional changes. You also can have misaligned studs and headers around doors and windows. Joints should fit tightly because obviously as the structure is loaded, any gaps that are occurring in the framing, you're going to have, those gaps are basically going to be taken out, and that can cause certainly ridging in the gypsum. And headers should fit tight against the top plate of the wall or cripple studs above the header. So again, just doing a good job of framing can certainly help mitigate some of the problems. Gaps between wall top plates due to improper attachment can cause problems. Between studs and plates, if you're not using a pre-trimmed stud, and you have varying stud lengths by a little bit, so that makes unevenness in your wall, that can cause problems. And then long walls or ceilings with no breaks, because typically gypsum is going to require having some type of a expansion joint put in, and we'll talk about that shortly in terms of what the requirements are from the Gypsum Association. Other framing issues that can contribute to gypsum ridging and cracking would be crooked framing members. Often, if the drywall, if the member is bowed or twisted to a certain extent, then the installer is trying to attach the drywall and they're missing some of the fasteners. That can cause problems. Poor insulation installation can make drywall very difficult to attach and can lead to excessive stresses in the gypsum joints. What can help prevent gypsum ridging and cracking is using kiln-dried lumber and trusses, which I'm sure most everybody in this call is doing, and then also helping to condition the building for at least 24 hours prior to installing the gypsum board. The studies also found that using resilient channel between the gypsum board and the ceiling framing can also have a significant reduction in the prevention of GRC. Now, the Gypsum Association in their construction handbook in Chapter 2, they have allowable deflection criteria that needs to be considered in terms of making sure that the gypsum doesn't exceed, and the framing materials that it's attached to don't exceed their deflection limits. For drywall assemblies, an L/240 is typically desirable. Limit of L/120 and L/180 in some of the codes. And then for veneered assemblies, it's L/360 with a limit of L/240. And then also making sure that the structure is designed for the minimum lateral loading, which for interior partitions is 5 pounds per square foot, and that's typically a requirement in the building code. And then exterior walls that can vary, but that can be as much as 45 pounds per square foot or greater depending on the height and geographic location. So again, making sure that the framing, the structural aspects are capable of, are stiff enough so that you don't exceed these limitations, and then also making sure that the gypsum is properly selected so that it itself is stiff enough between its supports to not exceed the deflection limits. Problems that with gypsum board issues that can contribute to GRC, typically cold, damp weather conditions can contribute to joint compound bond failure, delayed drying of the gypsum and the finishing materials, beading, nail popping, joint shadowing, and board sagging. Minimum required room temperature for mechanical installation of gypsum board with nails or screws is typically it must be at least 40 degrees Fahrenheit. And if you're attaching the gypsum with an adhesive installation, then the minimum temperature is 50 degrees Fahrenheit. The Gypsum Association also recommends that you maintain interior temperatures of at least 50 degrees Fahrenheit for a minimum of 48 hours, and that the gypsum board must be completely dry before taping and finishing. And they basically say that it's best if the gypsum board is completely dry and at ambient temperature before applying any finish materials. They also warn that if a temporary heat source is used, the temperature should not exceed 95 degrees Fahrenheit, and make sure that the interior is well ventilated, because gas-fired heaters typically generate considerable amounts of water, which can greatly increase the relative humidity of the air. And if you don't have proper ventilation, now you're basically just adding more moisture into the construction materials, and again can cause some problems and in this case the cracking. Concrete surfaces should also be aged at least 60 days prior to application of gypsum board joint compound, textures, paints, and coatings. The drywall attachment should also proceed from the center of the panel to the ends and edges. Drywall must not be attached to the corners first and then left to hang prior to field being attached. And then control joints in interior ceilings without perimeter relief must be installed so that the linear dimensions do not exceed 30 feet and the total area between control joints does not exceed 900 square feet. Not going to get you into problems with some of the smaller houses, but certainly some of the larger homes that have huge great rooms. This is an issue that's often overlooked, or a requirement that's often overlooked. So best practices then, from a component manufacturing standpoint, that in terms of providing guidance to customers, would be to first of all verify that the truss design deflection meets the U.S. Gypsum specification as stated in their Chapter 2 handbook, meets the deflection criteria, which would be a limit the deflection to L over 240 and never exceed L over 120, and preferred limit for veneer assemblies is L over 360 and should not exceed L over 240. You also want to verify that the trusses are level and the ceiling plane is flat by measuring the various locations using a laser level. Gypsum installation should occur only after the framing techniques are of sufficient quality to avoid acceptable movement in the framing members. And if the trusses are not level, it's recommended that they do not attempt to stiffen or alter the trusses without getting approval from either the building designer or modified details from the building designer, the truss designer, or the truss manufacturer. Drywall contractor should document the following items as stated in the U.S. Gypsum Construction Handbook regarding drywall installation. The date, time, and temperature and humidity at the time of drywall application, the method and how long the structure was conditioned prior to installation, if ventilated, the method of ventilation, the type of joint compounds used, and the type of finish specified and what was implemented. By doing this, at least they've got information that they can, if there's a problem that occurs later on, they certainly have that information and they can show that, yes, they've been following the requirements of the Gypsum Association and U.S. Gypsum. It's important, as we stated earlier, to allow materials to condition at the site prior to installation and allow materials to condition for 48 hours prior to joint taping. Use of resilient channels can certainly help reduce GRC. The backblock, the gypsum board joints, it's typically more expensive to do this. However, it does help in terms of reducing callbacks and dissatisfied customers. Prior to installation, again, inspecting the framing to eliminate as much as possible gaps between the framing members that could affect the wallboard installation process and cause problems later on as you get settling in the structure as loads are applied, again, causing ridging or cracking in some instances. Should avoid using wet lumber, and then use control joints in long walls and ceilings, and again, linear dimension not to exceed 30 feet, and total area control joints not to exceed 900 square feet. There are several good resources that you can go to. There's the Gypsum Association, Drywall Finishing Council, and then DRJ's best practices, which you'll find on the website. That you find a link to on the website for the Structural Building Component Association. And then there's also several good references for by the Gypsum Association or the Drywall Finishing Council. And again, this slide shows that link. And as Trish indicated, I don't know how many of you were on the call at the time. After this presentation, you'll get a copy of the presentation sent to you, and so you'll have all this information at your fingertips. Another cause of gypsum cracking that you'll typically run into, most of the calls that we get are in the northern parts of the United States, cold weather areas would be what's the industry refers to as partition separation.
They for that area they called for 2x6 floor joists.
Yeah, there was something goofy about all that. I remember that.
Hey guys, somebody's on here that we're getting feedback from somebody talking. I don't know if. Anyway, so partition separation is our industry defines it. The metal plate connected, or the structural building component industry defines it as partition separation is cracking that develops in areas typically adjacent to interior partition walls. It can occur either at the ceiling or floor level, usually characterized by gaps that open in the winter and close in the summer. So again, it's cyclical also. So here's a prime example of what partition separation can look like. We have an interior partition. We have our trusses, in this case, that are spanning across that partition. And a gap has occurred between the ceiling level and the top of the wall. That again is typically seasonal. Worst case that you'll see is typically in the wintertime, and then in the summertime this may go away and then come back the following year, and then continue to do that unless it's determine what's causing the problem and that problem is corrected. There are many causes of partition separation. They can either be acting independently or combined as a group, okay? One of the causes can be building settlement. Footings are either improperly sized for the given soil capacity. The footings are too shallow and are subject therefore to freezing and thawing cycles, and therefore causing movement in the footings. Or footings can be near seasonally fluctuating water tables. Certain parts of the country have very expansive soils that if you don't use the proper techniques can cause problems with movement in the footings. So again, building settlement is one thing that can certainly cause partition separation. You can also have, again, inconsistent framing practices, uneven stud lengths. Trusses can be designed with bottom chord camber, which perhaps is not correctly dealt with in the field. That can cause problems. Moisture effects can also cause partition separation issues. Again, individual wood members used in typical platform frame structures shrink and swell significantly on a seasonal basis due to changes in moisture content. And I might add, typically when we're talking about moisture content there, it's really more of a ventilation issue where things are not being vented properly. Sometimes deflection issues or under design from a deflection standpoint can cause problems where you've got differences in the deflection of various materials. Trussarching, typically that's what's blamed, especially if you're getting a call where someone's got a truss arching problem. And then also, as I said before, it can be a combination of any of these factors. So by truss arching, this is typically a movement that's due to a significant differences in the moisture content between the top and bottom chords of the trusses. Arching is typically not associated with any structural problems. And what we're showing here is, okay, if I have my typical roof or typical roof truss, and again in cold weather climates, typically you're going to have the bottom chord is going to have insulation and then be encapsulated in insulation. Top chord's typically exposed, and if your ventilation is not adequate, or if there are sources of high moisture that are, whether it be kitchen vent fans, bathroom vent fans, that are venting into the attic space and are not properly venting out into the exterior, what can happen in the wintertime is you get this warm, moist air working its way up into the attic space, and you can actually have that warm, moist air condensing on the top cords of the trusses, which is just like putting a soaker hose on that truss. And so now that top cord, the moisture content is increasing, and as wood takes on moisture, it wants to expand. And the bottom cord, which is in the insulation and close to the finished area of the house, the warm side, typically is staying at a much more controlled moisture content. Or if it's drying out, it could be causing it to want to try to shrink, so that's pulling. And what you end up with is this arching effect where literally the truss will arch, and if I have a interior wall in this area and it's not connected properly, you can end up with this arching and a gap occurring between the bottom cord of the truss and the top of the wall. And again, classic here, in this case, it can be pretty significant. In this case, you're talking about a 3/4 of an inch gap that has occurred between the ceiling level as the gypsum ceiling has gone with the truss and separated from the gypsum wall at the top of the wall.
Jim, there's a question.
You can also have it occur.
Jim, there's a question from the audience. Someone asked, how does spray foam affect moisture content?
That's a real good question. We actually, if you're aware of any issues that have come up using spray foam, please give us a call. We actually have a form that we're trying to, or we have a form available that we would like to have people fill out to determine, so we can get a better idea in terms of just what, what some of the problems are. Well, we're aware of some of the problems, but you've got different types of foams. You've got more of an open cell foam, which is supposed to allow the moisture to move more freely. You've got closed cell, which can encapsulate. There have been issues. Spray foam is used in a lot of applications, or a lot of that's become pretty popular. So it's not something where I personally have not received. Probably the last time I took a call regarding a spray foam or a truss arching, if you will, issue, or partition separation issue where spray foam was used, it's probably been about 1.5 years ago now. But if you're getting those types of calls, please give me a call, because we're trying to set up a database to better understand what some of the issues are. But yeah, it can occur with spray foam as well. And what this photo is showing is, if the connection between the bottom cord of the truss and the top of the wall is adequate enough, you could actually lift the wall off the floor. And I have personally seen that, and this particular photo is also showing that that can happen. As you can see, with the tape measure being shoved through between on the top of the carpet underneath the bottom plate of the wall, because this case, that wall is basically lifted right up with the truss. Certainly shows. Remember, we talked about how with partition separation, it's typically not a structural issue, but it certainly shows that there's some significant forces that are developed due to these differential dimensional changes that are occurring, which can certainly cause issues, but not from a structural standpoint. It's not damaging the truss or anything like that. So what are some what can you do to correct and prevent partition separation? Well, first of all, you want to correct the partition separation by first determining its cause. Okay, it's kind of hard to solve a problem if you don't know what's causing the problem. Check the plane of the interior, exterior bearing, and non-load bearing walls, as well as the ceiling with a builder's transit level or laser level, to determine that the building is moved, if the building is moved, and aid in the planning of the solution. Specific solutions for partition separation should be handled on a case-by-case basis by a qualified building contractor. In the majority of cases, retrofitting the floating corners with appropriate back blocking solves the problem. Now, I mentioned, this is not necessarily a new construction issue. If it's new construction and the house has been typically, gone through a couple of 1 or 2 heating and cooling seasons, you're typically, like I said, if the ventilation is not adequate, and you're getting moisture up into that attic space, what you're going to find is typically in the wintertime you're going to get that gap occurring, and then it's going to close up or minimize it in the summertime, and then the following winter it's going to come right back again. Okay, so that's new construction. You can also have this situation occur in 20-year, 25, 30-year-old homes, okay? And typically what happens there is the homeowner decides that they want to increase their the amount of insulation in the attic space. And so either they do it themselves or they have somebody come in and they add more insulation, and in doing so they end up plugging or impeding some of the ventilation, which now reduces the ventilation in the attic space. And I have taken calls where people had, a 20-year-old home never had an issue, and all of a sudden now they're starting to have this partition separation, or the separation between the the ceiling and the wall. And in every case, it's been that they had added some insulation to improve the thermal properties of their home, and from the energy efficiency, and next thing you know, they've got a problem. So it's not necessarily a new construction problem. What are some ways that you can go ahead and solve the problem? And this information is out of our the Structure Building Component Association has a document, Truss Technology in Building, and it's Partition Separation, Solutions and Preventions, or Causes, Solutions, and Preventions. And that's a document that's available on the website. But basically, what we're showing here is a floating gypsum corner where typically you've got the bottom cord going across the interior partition. And what everybody wants to do is they want to go ahead and attach the ceiling basically right at this location right here. And so now when that truss starts to move, guess what's going to happen? That ceiling is going to go right with it and cause separation right at this location here. So what this detail is showing is, instead of attaching the gypsum right here, you basically float the corner, and you don't put any screws or nails for the gypsum any closer than 16 inches to the top corner of the wall. That way, if there is movement, if you can't get the ventilation under control so that you are going to have movement, at least what's going to happen is now this gypsum can kind of float. And there's also, what you can't really see very well, is there's a clip angle right here that basically is attached to the top plate of the wall that holds that gypsum in place. So if this bottom cord wants to move, that it can raise up enough that you can have a gap occurring between the top of the gypsum and the underside of the bottom cord of the truss, and you won't see it from down here. Okay, so that's one option. If the trusses are parallel to your partition wall, again, you float the corner and you put this angle clip in. And so now if this truss wants to move up, it's basically not going to take the gypsum with it. Okay, so 2 floating corner options. There are also other ways that this can be done. During construction, or even as a retrofit, you can add, if it's a 2x4 partition wall, they can add a 2x6 plate centered on the wall, and you attach the gypsum to the plate but not to the truss. So now when the truss wants to move, it's basically moving in the notch between the 2x6 blocking on either side of it, but it's not taking the gypsum sheathing up with it, at least at this point. Again, and you're floating, or you're holding the closest fastener into the bottom cord of the truss is 16 inches from the corner. The other And I see that somebody made a comment here about I have had drywall installers act like this is new information. Yeah, the one thing I want to caution you on it too is these are recommendations from the Structural Building Components Association. You need to be careful if you're in a commercial project where you have to have a fire-rated assembly. Certain fire-rated assemblies have a very specific fastener attachment requirements, which you won't find any of them that have been tested using a 16-inch floating the corner back with 16 inches. This option should basically still work, however, but you know, in terms of, because you still are attaching along the perimeter. So, but just be aware of that certain fire-rated assemblies have very specific fastener attachment. And then finally, another option is you can use a slotted bearing clip. In this case, the slot is vertical. And the idea here is that as that truss wants to move up, it can slide up and down in this slot. And again, with these clips holding the gypsum, and then you'd have the closest fastener in the bottom cord from the corner of the wall is basically going to be 16 inches out. Okay, got some other questions. One of the questions is, are these same details available from the U.S. Gypsum Association or other gypsum organizations? No, I don't believe they are. I do know this, back in the 90s, at that time, the Engineering Review Committee for SBCA did send these details off to, I believe it was the Gypsum Association, and asked for their blessing. And I believe we got a letter back saying that they didn't necessarily take issue with what we were proposing here, but they wouldn't go as far as to endorse it, you know, officially endorse it. So to answer your question, no, these are details that are provided by the Structural Building Components Association, but have been used successfully. So it's not something that we're springing on people. Okay, let me go back here a little bit here. Got a comment that STC Clips, and that, I believe, if I'm not mistaken, this is an STC, well, Simpson calls it an STC clip. Yeah, it's a slotted clip basically. And yeah, that can help. The comment was that STC clips can help in sealing separation, in particular northern climates. That is correct. What's the best way to inform framers not to toenail the truss to interior bearing walls? That's a good question, because you know, I think it just is human nature to, you know, want to nail things down wherever you have framing members going across, say, walls or what have you. You want to attach them, and the STC clip certainly is one option that allows you to attach. You know, I think the main thing is if you know, we tend to learn by our mistakes, and as people go ahead and toenail. Now, you know, and I'm sure there are instances where they have toenailed the bottom cord to the top plate of the wall, but perhaps the forces are great enough that that toenail connection is not what I would call a real solid connection. And as that bottom cord starts to move, there may be instances where those nails basically are going into withdrawal and are being pulled from the top plate without really knowing that the occupants under, you know, beneath the ceiling knowing what's going on, because you're not seeing any cracking. But yeah, I think if you're in a northern climate area and you've run into this problem with a partition separation, easy for me to say, if you've run into the problem, having a document, either the SBCA document or having some information regarding some of these issues and ways that you can frame around it are probably a good thing to have, and maybe start. I know there are some truss manufacturers that do provide this partition separation, TTB, as part of the job site package, just to make sure that everybody in their area is aware of the potential problems. Question, what if there is no separation between the wall and ceiling, but there's a sagging of that occurring? Is that most likely a... okay, so in this case, if I'm understanding this question correctly, there's no gap at the interior walls, but what you do have is that there's a sag in the ceiling. Yeah, that probably, well, it could be for several different things, but that could be a case where perhaps there a portion of that bottom cord of that truss there was a sag in that bottom cord to begin with. That's one option. And that's the other thing too. If you have a sag like that, you don't necessarily want to just go in and plane the truss. I know truss planing occurs in some locations, but just be aware that the American Lumber Standards Council has very specific, you know, when you're using a piece of lumber, that lumber has been graded for its growth characteristics and assigned a visual grade, okay? You are allowed to cross-cut that piece and still maintain the grade. However, if you rip it, which you're doing basically by planing, you now have potentially changed the grade of that lumber, and you're typically not changing it for the better, okay? And the thought process there is, you know, the lumber properties, the grades, visual grades, have to do with they allow certain size growth characteristics, i.e. knots and so on and so forth. And you're allowed to go with a larger knot in the wide face of the member than you are in the edge. Okay, well now if you start ripping the material or planing it down to try to take out a sag in that piece to level off the ceiling, what you're potentially doing now is that larger knot that's allowed in the wide face, you're now getting that closer and closer to the edge of that piece, which potentially can drop the grade of that material considerably, let alone the fact that you're now making that cross-sectional, the dimensions smaller. So anyway, to answer your question, yeah, the sagging certainly could be because of you've got a bottom cord that maybe when it was manufactured, they improperly placed the wood so that the crown, if there was a crown in that piece, it was facing down instead of up. I think I've got most of the questions covered here. Yeah. Okay. Well, thank you very much. I appreciate your questions. And like I said, or as Trish indicated, we'll be sending this presentation out, so you'll have the information regarding some of the documents that we use to put the presentation together. Thanks, everybody. Have a great day. Bye.
Everybody learn something? Thinking about that, Trussarching.